CAMplete toolpath, talk about post-processing, the G code, follow it up, how CAMplete would be a good fit for your business, give you a short demo, and then we can do Q&A. I wanted to introduce to you guys Jeff Fritsch. Jeff Fritsch has an extensive experience in CAM. Jeff, I don't want to steal your thunder here.
Well, again, thank you very much for everybody that has joined us today to learn a little bit more about CAMplete and TruePath and really where that fits into your overall manufacturing process. So just like Andy was mentioning, I've been with Autodesk now for just over a year since CAMplete has been acquired by Autodesk. But prior to the acquisition, I've worked as an application engineer for different CAM systems, including NexGenCAM and NXCAM, and joined CAMplete 11 years ago, and I had a 10-year stint with CAMplete, both as a product manager and eventually switched over to sales and ended up looking after all the commercial activities of CAMplete, including to a certain extent the overall acquisition of CAMplete by Autodesk. So joined Autodesk about a year ago. Working currently as a product specialist, sales manager, and basically I'm responsible for all aspects of the CAMplete products as a whole, more specifically on the sales and the commercial activities. So that being said, really the focus of the conversation today is really what is CAMplete? Where does it fit into your process? What would be the benefits for users? And as a whole, really, what added value would you get from this new Autodesk product? So the best way to really put that into perspective, and as everybody know, a picture is worth 1,000 words. Let's just start with a quick video really highlighting that process and where it fits into the overall manufacturing process. So that video that I'm showing here is a quick demo part that we actually did in partnership with Autodesk at the time when we were still CAMplete. But really there, the focus is on the application and where users would typically run into issues with multi-axis machines. So in that particular example, the manufacturing operation represented here is a very simple drilling operation. So in that case, that was programmed in one of the earlier versions of Fusion. But as we can see here, the manufacturing operation itself is very simple. It's simply drilling a coolant hole through the tombstone to be able to drain the coolant out of it. So from a machining perspective, this is a very simple operation. Simply drilling, push the drill into the material, remove the drill, and that's really the end of the operation. So as far as the CAM system is concerned, it is a very simple motion, very simple movement for the machine. However, once we put this very simple operation within the context of the machine and consider all the elements that go around the actual toolpath, that's when we can actually notice that indeed that very simple operation turns out to not to be as simple as represented on the screen. And at that point, tools like TruePath are really here to help put this into perspective and make users aware of any possible issues that may come out of this very simple machining operation. So again, once we put that into the real machine, we can very quickly realize that at that point, having a digital twin that will accurately represent the real movements of the machine and put that into context, that indeed that very simple operation can present some very real challenges that can have some real consequences both on the machine itself, but also as a whole in the overall operations of the shop, and obviously have a financial impact if something is not going the way it is supposed to happen. So really, TruePath and CAMplete as a whole have developed tools to really help identify those issues. And as we're mentioning previously, if those issues are not detected ahead of time, just like they are in the video now, that can have a real impact onto the machining operation, the quality of the parts, and just the overall impact that it will have on the shop. So at that point, obviously, scrap part, broken tools, machine damage that at that point become very expensive. And it's not just simply the replacement parts for the machine, but it's all the services that go around with replacing those parts. That means bringing service engineers in, paying for travel expenses, and there's an overall downtime for that equipment. And crashing machine will never bring it back exactly to the same condition that it was on previously. So as a whole, this is really where TruePath will be in place to really help customers understand the overall manufacturing process and being able to control this. So in order to do this, there's really three main pillars that TruePath will be focused on. The first one is really heavy on code generation, post-processing. The second one will be really making sure that the equipment itself will be able to run the code that has been created. And ultimately, the third pillar would be to really being able to address those issues in the same environments and making sure that those resolutions are reflected appropriately in the code. So from a code generation perspective, post-processing, really the best way to put this into perspective for users that may not necessarily be familiar with the environments would be to do the analogy with a printer driver. So when a document is created and you go to print it, you simply click print, and there is no second thought as a user as to where the printer head has to go, how fast does it have to move, how much ink gets dropped at every line that gets printed. Really, the process as a whole is very streamlined and very easy from a user's perspective. And all of that information on how the printer actually handles that information and does the actual printing job itself is handled by the printer driver. Now, would there be any type of issues with that driver? Of course, something will be printed out, but not necessarily what we're expecting to have and have that match one-to-one with the original document that is to be printed. So taking that concept into our world of machining, this is exactly the job of the post-processor to convert the instructions that were created by the toolpath into the CAM system into a set of instructions that the machine tool itself will be able to understand and recreate the appropriate motion to generate the parts that are needed to be machined. Again, would there be any type of miscommunication or information not generated appropriately? Again, something will be produced, but not quite the parts that will be in a state to be able to be shipped to your customers where you're able to get paid for it. So really, the essence there is to have proper codes to be able to drive this machine tool accurately. And this is really where TruePath will come into play to make that connection happen between the CAM system and the machine tool. And regardless of the platform that is being used to generate that toolpath information, that connection with that particular machine tool that is installed on your floor is really what's going to make that conversion, if you want, from digital to real worlds effective and accurate enough to be able to produce proper parts. So very often over the years, we have obviously encountered thousands of customers, but over those thousands of customers that we've seen over the years, there has been a very common theme as to how do we go about getting that proper code. And obviously, the technology of those machine tools is increasing every year. There is more and more advanced functions to be able to create more and more advanced parts. And those functions do require a specific set of information. Very often, machine tool companies tend to develop new machines, and the software industry tend to play a little bit of catch up to be able to support those machines. And now we see a lot of introductions of 5-axis machines that have more advanced functions with TCPC, dynamic work offset, 3D cutter comps, probing capabilities. Some 5-axis milling machines also have turning capabilities. So really the boundaries of the limitations of the equipment are really blurring. And at that point, this is really where having a tool where we can accurately generate code, making sure the equipment will be able to handle it, is really going to give you a very detailed insight into your overall process and lets you utilize that knowledge to be able to proactively improve your process so that that equipment can be used for what it's really good at, which is making chips and not necessarily troubleshooting programs. So at that point, again, being able to proactively being able to detect any possible machine issues, whether those issues may be at the code level, maybe with all the peripherals around the toolpath, such as, for example, fixturing or tooling, possible machine limits, maybe codes that may not be interpreted appropriately, collisions, are really elements that now TruePath will be helping to detect, but also as a whole, being able to, again, proactively improve your part quality, and as a whole, have a lot more understanding and predictability into the overall manufacturing process, and ensure that now that transition from the virtual to the real world will be as efficient and as close to the reality as we can possibly make it. In terms of collisions, of course, there will be a few different areas throughout the process that will be presenting challenges, and that the CAM system in itself is not necessarily looking at. The primary focus of the CAM system will be to generate the toolpath, but that doesn't necessarily mean that the machine tool that you as a customer will have is necessarily able to follow the motion that was generated by that toolpath. Whether that happens during the cutting motions, as we can see here, there's some interference between the spindle and the table, whether those movements are happening during the tool change position, where the CAM system simply assumes that the tool will simply start at the next position, or effectively during those positioning moves where, again, the CAM system is not necessarily looking at the same behavior as the machine actually would do. So at that point, how do we go about solving those issues and giving you that insight of really what the machine will be doing is really what I wanted to dive into a little bit more today. So reiterating that point, really having proper code, having a post-processor really dedicated to that machine is really going to be the first step into assuring that this transition will be happening effectively. And what we're really hammering there is really having the digital twin of not only the machine, but the process as a whole is really what's going to let you visualize all of those movement, all of those intricate behaviors that the machine will have that are really specific to every machine tool, and not necessarily to all of them, but each machine will have its own behaviors. And at that point, having that digital twin in place will help us really address those needs. So to be able to do this over the years, CAMplete and obviously now Autodesk have worked very closely with specific machine tools to be able to have that primary information from the right sources to be able to support the entire machine line, but also being able to work with obviously Autodesk, but also other CAM system vendors, so that at that point that gives users the flexibility to use the most appropriate tool for the job that is to be completed. So where TruePath now fits into the picture is not to replace the CAM system. We're not here to replace that as a whole, but we're really here to complement the CAM system and give the user that flexibility and that control to do the manufacturing process the way you guys would want to make it. So that means from a post-processing and verification perspective, we'll have that ability to bring in multiple sources of information, multiple data input from different CAM systems into the same project. So we'll dive into that once we look at the software in a couple of minutes, and have that understanding of how the code will have to be generated for a particular machine, making sure it's going to be running the way the machine expected to, and would there be any issue, how having the tools in place now to be able to address those. So code generation really going to be one of the big pillars of that. The simulation side, again, will have a very big impact on how the machine will be able to run that equipment. So again, having very detailed information for sure presents a very nice picture, but this is really the level of detail that we want to get into to ensure that we can have that digital twin that's really matching one-to-one with the real machine, and making sure we can provide that level of detail and that level of understanding, so that would there be any issues with the code, whether it is on the over travel, collisions, or really anything else that could go wrong, that all of those elements have been looked at, are understood, and now we can take the proper action to make sure everything falls in place the way a user would expect this part to be running on that machine. And ultimately, would there be any issues? Again, having the tools in place to now being able to address those issues and potentially help you look at better alternatives to fix those possible issues. So very typical examples would be, for example, which side of the trainer we're tilting on, how do we correct over travels, and as a whole, having a very good understanding of the process and the behaviors that the machine will follow throughout that process, so that at the end, this is really the holy grail and what everybody is after, really being able to have the assurance that the parts that will be produced by that process will be good enough, so that you as a customer will be able to send that over to your customers and get paid for it without tying the equipment down with unnecessary, I guess, program validation on the machine tool, and really let the machine run and make the chips and really use it for what it is usable for. So at this point, I'm going to stop the presentation here. We still have a few slides that we'll come back to at the end, but I think at this point, I really want to be able to jump a little bit onto the software side and really show you what the software is all about. So in here, I do have a very straightforward parts. I have that same part programmed in multiple CAM systems, so that now we can start to show you a little bit of everything on that process. So I do have this part programmed here in Fusion 360. I had it as well in PowerMill that I just had up on the screen, and I also have that part programmed in a competing Autodesk product, in that case NXCAM, which is another very popular CAM system. So at that point, from a programming standpoint, everything basically stays the same. There is no customization whatsoever on the CAM system side. The programming effectively continues the same way you have been programming up to that point. The first major difference that you're going to see now will be that instead of post-processing for a particular machine tool, what we're going to do now is transfer that entire project over to TruePath, so that we can do the code generation, do the validation of that code, and fix any issue, would there be any issues to fix. So at that point, this is handled here through a CAMplete APT output specific to, in that case, Fusion. PowerMill will have a plugin, again, that will do all of the heavy lifting and transfer the same type of information. So that information that we'll be looking at here will be, of course, exporting all of the different toolpaths in the project as a whole, but also grab all the peripheral elements that are related to that toolpath. So namely, that would be tools, holders, in that case, parts, model, fixture models, stock models, what machine will be running that particular project, and that same type of information will be exported from each CAM system in a very similar fashion. So again, for NexGenCAM, there will be a plugin that will export very similar information, and we're just going to start here from the Fusion side of things, where again, here we'll grab the fixture, the part, the stock, and export everything from there. So really at this point, I will simply use the CAMplete APT and click post, and all of those elements will be exported directly into a folder that I had here defined on my desktop, and TruePath will now pick up that information and we'll start running it, and we'll start interpreting everything that will be happening. So the first step into that process, once all of this information is loaded, is really defining what machine tool is going to run that particular project, because that machine tool will have a very particular set of instruction that it will need on the controller side, will have very specific travel limits and just limitations as a whole that every machine tool will have. So at that point, the machine tool is really going to be the first elements that we'll be selecting. Second one, and that's really just verification of the information that came through, will be obviously the type of information that will be processed. So of course here everything matches one-to-one with what we had defined on the toolpath side of things. So all of those toolpaths came in, the type of toolpath it is, if we're working tooltip, tool center. So really some information that we can already start adapting now to what the machine is capable of doing. And of course, all of the tooling information that has been transferred over as well, so that we don't have multiple tooling databases to maintain, one on the CAM side, one on the simulation side. All of those information points already have to be known at the time of the toolpath creation. So it's really just a matter of using that information and putting that into context. So at that point, once I've simply reviewed that information, I can start loading this information, and then we'll see all of those elements really come together. So that means obviously the toolpath, the fixture, the part model, the stock, where all those elements are located into the machine environment. And at that point, this is really when we can start doing the actual code generation. So the software will check in the background what type of information has been used, how it is handled, and will it start introducing some errors so we can see how the software will react to it. But really at this point, this is now the stage where we do have the G code that has been created, and now we can really start verifying exactly what that resulting motion in the machine tool will be from the toolpath that has been created. So at that point, would there be no issues detected or anything to report, we can literally export the G code, get the setup sheet that goes with it, and take this code and go put it on the machine and have the assurance that everything will be running as expected. So that would be a very straightforward workflow to go, for example, there from Fusion 360 to having G code. This is a very simple operation. We'll simply use the CAMplete app, click post, everything gets transferred, we pick the machine, and we have G code. So to get to that point, very straightforward. Where it becomes a little bit more interesting now will be to, for example, use multiple CAM systems input into the same project, and now being able to leverage multiple tools to do that project. There's multiple reasons why users would want to do that, whether it is a preference to program in one particular CAM system. We do see a lot of customers using, for example, contract programmers that, again, have their own set of tools. So at that point, that will be one way to remove the post-processing issue out of this using contract programmers. Or we have other customers that do have multiple locations where the programming is done in one location, but the manufacturing itself may be done on the other side of the city or country or other side of the world. We have seen just about every scenario there. The point there is really now being able to work from multiple CAM system sources into the same project. So originally there, we brought all of those toolpaths directly from Fusion 360, but now I can also start bringing in toolpath from other CAM systems. So in that case, I have exported similar data from NexGenCAM. I have some toolpath coming in from PowerMill, so I can start bringing in some toolpath here from PowerMill, and I will simply add them to the existing process that I already have in place. So I'll simply add them to my existing program, and that will be the end of it. But at the end of the process in itself, I will still be using the same code generation engine. I'll still be using the same post-processor to generate the code for that procure machine tool. So now the process becomes a little bit more interesting, where I have some Fusion 360 toolpath that I started from, I have some PowerMill toolpath that I started from, and now I'm going to add a little bit of 5-axis as well, and I can use, for example, there some toolpath that was created from Siemens NX, and again, add that exactly at the end of my existing process. So as soon as, again, that information get brought in, the software will analyze all of this information coming in, and now we'll see that, for example, here, now we'll have conflicting information on the tooling. We have the same tool number that is used twice, but the actual tool geometry in itself will be different. So that is one of those scenarios that we physically cannot have in the machine and will create a pretty drastic error from a code generation perspective. So as soon as, again, now we're going through the post-processing using the same engine, whether the data comes from Fusion, from PowerMill, or from NX, now we can see that this tooling conflict is going to create a pretty big problem. So we have, in that case, two particular toolpaths that are now presenting those issues. So now that we've brought all of those elements into the same platform, this is really now where we can start identifying some of those issues and start fixing them in the same environments without having to go back to each one of those CAM systems that has been used to break toolpath in, whether it's PowerMill, Fusion, MasterCam, NX, it really doesn't matter. We have all of this information centralized in here for that process that will be running on that particular machine tool. And at that point, we can really start addressing those issues. So in that case, there may just be a simple tooling issues where I'll be able to relabel some of those tools and see those changes reflected immediately into the process and make sure that now we'll be able to, I just want to make sure I address those appropriately myself and not introduce more errors in here. So let's just go in here. And at that point now, I'll be able to, again, regenerate the code, make sure that there's no more issues, at least on the code side. The same way, the background information that will be used to generate the code will be checked. So what I'm talking about is, for example, is there a tool defined? Is that tool actually put in the spindle? Is the spindle getting turned on? Do we have a plane defined before an arc move? So all those scenarios will be checked. So again, we can keep the code generation very consistent and being able to start validating what is happening. So I'm not going to go too deep into some of those details there on, modifications, but at that point, obviously, tons of control on what is happening at the process level, reorganizing those operations, where the software will take care of some of the transition, what source of information has been used to generate the codes. At the toolpath level in itself, there will be a lot more flexibility on how the toolpath in itself is put together. And ultimately, that particular toolpath is now going to produce particular G-code output. So all of those elements will be able to be controlled independently from each other or as a whole, as a process altogether. The next step at that point that we have, now that we have the code, will really be validating this code. Can the machine tool, with its own limitation, will be able to generate and run this toolpath without creating any particular issue? So what we call the technology that goes around the toolpath is really an example of some of those points that I'm talking about. So the first thing we did, for example, was to change the tool number. So again, if we go to change the tool number, chances are the offset number will want to be matched as well. So again, being able to see those changes reflected right away. My spindle speed on the roughing was probably on the slow side at 500 RPM. So maybe we'll put those at 2500 RPM and again, have those changes reflected immediately. Same thing will hold true with any type of feed rate, whether it's for the plunge, for the cut. I can see on my first operation, there was no coolant defined. So I want to make sure I have at least the mist or the flood active so that I can wash all of those chips away. And ultimately, also now being able to start adapting some of those machine behaviors to the machining operation that we're trying to do. So the first few operations were really focused on 3-axis roughing and really being able to plunge the tool into the material and remove as much material as possible. So really focus here on 3-axis roughing operation. If we look at some of those drilling and tapping operation, at that point, the objective of the cut will be slightly different than a 3-axis roughing operation. Obviously, there will be more focus on drilling and tapping, which will have different focus and different settings internally in the controller. And ultimately, some of those operations at the end, they're, again, focused more so on the 5-axis type of thing. So very different, again, machining objective, very different machines behaviors. At the beginning, we're really focused on heavy 3-axis material removal, plunging the tool, removing as much as we can. On the 5-axis motion, the objectives will be different. It will be a very light cut, very dynamic, but at that point, we really want to focus on the smoothness. We don't want to have any type of jerkiness or strange acceleration in the corner. We really want to focus on a very smooth motion, very accurate, very dynamic, so that we can have the finish that we're wanting to have at the end. So as a whole, now really being able to adapt the machine's behaviors to the objective of that machining operation. Again, being able to bring all those elements back in place and now have the proper codes that reflects all of those changes that now we're introducing to really make this toolpath fit into what the machine will be capable of doing. So at that point that I have this code in place, I really want to be able to, again, kind of jumping ahead of myself here a little bit, but I want to be able to now validate all of those movements. So the software now, simply clicking play for the simulation, the simulation itself will be driven by the code. So we are doing full G-code simulation. This is not running from the toolpath data. This is the simulation is driven by the actual G-code. So any changes in the code will be immediately reflected into the simulation. In the same way, any simulation changes that we'll be doing here, or any changes that we'll introduce on the machine's behaviors, will be reflected into the code. So at that point, obviously, I'm not going to be watching that simulation run at the regular cycle time. I'll really want to be able to fast forward throughout that process as a whole and really have the software warn me or stop the simulation if there is any type of errors that would be found, so that at that point I can really start focusing on the problematic areas and fly over everything that is working as expected. So in that case, one of those first issues would be, for example, an overtravel. So the toolpath that was created into the CAM system at that point is really looking at, as we saw in the first video, really the interaction of the tool with the material. That doesn't necessarily take all of the machine's peripheral, if you want, into consideration. So one of those considerations to take is, for example, how the machine behaves, where some of those limits may be located. So at that point, we can see very clearly that trying to reach that position would create an overtravel. So the machine itself is not physically capable of reaching that particular location. That machine in itself can only reach 35 degrees rotation on that particular position. That will be the max travel allowed on that side. Obviously, there is a lot more travel on the other side of the train. So at that point, again, within the limitations of the machine, we'll want to be able to now flip that solution. Still reminding myself that I'm working in that case from 3 different CAM systems. So I'm using Fusion, I'm using PowerMill, and I'm having some Siemens settings. I have all of those points centralized in here, and all of those toolpaths are valid. We simply want to make sure that now we're able to make those toolpaths fit within the work envelope of the machine. So at that point, again, I'm not going to go back to each one of those CAM systems, correct the issue in the CAM system, regenerate everything, and re-import all of this information. The toolpath intent in itself, the cut in itself, is proper. What I really want to do now is being able to flip that solution and pick the alternative positioning for that part and make sure that everything now will be working as expected. And now we can very clearly see both on the graphical side, which is reflected immediately, that we're picking the other solution, and having now the code reflect those changes as well to make sure that all those elements are staying compatible with each other, and that the code accurately reflects the changes that were brought forwards through the simulation. So that is really where the digital twin will be coming in place. So from where we left, I'm just going to go back quickly and run through all of those elements again, make sure that now we have passed the point of that overtravel until we reach the next point, where now we're going to have to look at another type of error, which in that case would be a real collision. So that will be a real interaction of the spindle with the table. And at that point, really making the case of being able to look at the process development. So what I'm talking about here is not only being able to identify those issues, but now being able to proactively take the steps to correct those issues. So in that case, being able to look at, for example, alternative scenarios that can help resolve that actual collision. So one of those elements, for example, that we could be looking at would be, again, talking about the tooling. So now if we can start looking at alternative holders, extend the gauge length, maybe look at alternative solutions on the fixturing, or as a whole on the setup in itself, because in that particular instance, the table of the machine is not symmetrical. I have a long side and a short side, so it may just be a setup question as to how the part itself is actually oriented when it goes and gets clamped on the table. So we're going to very quickly go through those elements and then quickly jump back onto the presentation. So at that point now I can import, for example, a riser that I could add onto my fixture. So adding the riser will add a little bit of height onto my fixture and hopefully enough that we can clear that collision. So in that case, I can grab that riser from NexGenCAM. So I will just bring that in. Again, I don't need to bring the entire project all over again. There are very particular elements I want to bring in and being able to look at. And of course, adding the riser will slightly offset the parts related to the table. So now I just need to quickly realign all those elements. And now I can see that riser has now been introduced. Still not quite enough to really clear that collision, but at least that's a move in the right direction. The next step we could be looking at would be, for example, on the holder. Again, very quickly changing the holder, extending the gauge length. There's tons of functions in the software that will help you navigate through all of those elements. Just going to quickly highlight those. So again, now I'm going to not change the cutting portion of the tool. This is really defined by the CAM system, but everything else around it is fair game and is really open to now any type of changes. So in that case, a holder that will have a little bit more reach. And again, the software will help us navigate, will help us find the shortest tool possible and so on. So in that case, I know it's about 1.5 inches. So again, now we've introduced that new holder. We'll see that holder reflected immediately into the simulation. And I want to make sure that those changes will be reflected into the code. But before I quickly jump into the code regeneration, I wanted to look at that scenario of possibly looking at what would happen if I just rotated my entire part 90 degrees when I go to clamp it. And now we can very clearly see that introducing that 90-degree rotation on the setup, simply rotating the part when it gets clamped on the table, would very easily solve that issue of that collision. So these are some of those flexibilities that that TruePath will let us bring in and really help you identify those issues, have the proper codes that goes with the resolution of those issues, and really making sure that all those elements will now be able to fit in place and let you develop the part properly, lets you really understand the process as a whole so that you're not using that machine tool to troubleshoot your process or your part, but really use it to actually make the part and have the assurance that the part that will be produced by that process will be exactly within specs and within the tolerances that you guys have specified, and that the machine tool itself will be able to safely run it without creating any issues. So obviously there's a lot more functions that we can dive into, and I'm more than happy to go through those if there are customers that are really wanting to dive a little bit more into it. But I wanted to quickly dive back onto the presentation side and really look at maybe more of the business side for literally another 4 minutes, and then we'll open it to questions. So as a whole, really, over the years, we've really looked at all kinds of customers that we've talked to over the years, and there's really two main types of customers that we've identified. Really, they're the first group of customers, I would say, are really customers that are really new to the 5-axis world, have a ton of experience using 3-axis machines, and are really now upgrading their own technologies, looking at multi-axis machines, whether it's 4-axis or 5-axis. And then at that point are really needing a solution that will help them transition into that 5-axis world. There's a lot of things moving at the same time, obviously 2 more axes moving, but there's also other considerations to take into account, such as how the toolpath in itself is actually created, how the tooling is handled, how the part gets fixtured, just like we saw in the example. So at that point, it's really being able to help those customers transition efficiently from 3-axis to 5-axis so that they can focus onto what is really important, which is really understanding the technology, becoming comfortable with all of those moving pieces, and really being able to focus on this and not worry about post-processing and crazy code and all kinds of other elements are distracting from actually making parts. So that would really be the first step for customers. And then really on the other end of the spectrum, we'll really have the high-end power users that want and needs that very high level of control on the toolpath, how all those elements are put together, and really have that very fine level of detail that didn't necessarily show here in that presentation, but more than happy to go back at it. So really, these would be the two main groups of customers, but at the end, they will all have the same needs, which are really articulated around post-processor, code generation, and really being able to identify those issues and make sure that those issues are identified and detected before they make it to the point of being on the machine. There's nothing worse than having a machine entirely set up and go, have the parts set up, the tooling set up, press cycle start, and you get 10 lines in and you have an error. And now you have to go troubleshoot this, and not really spending a lot of time making the part, but more so troubleshooting the process. So at that point, really, that's where TruePath is going to help you identify those elements, and also take into consideration. We've had multiple customers over the years really wanting to tackle that aspect of things on their own, and unfortunately ran into some difficulties themselves along the way, and ended up coming back and say, you know what, this is not my area. I would just want code that's going to work so that I can focus on what I need to do, which is really machining. That's what I enjoy. That's what my business is all about. I don't want to spend so much time, troubleshooting codes and post-processors and all this craziness. That's your guys' areas. Make sure it works. And that is really where we want to be able to help you address those needs. So at that point, this also comes back to, I guess, you as a customer to a certain extent to be able to say, okay, this is not my area, or I do have a guy that's really dedicated to doing that has the experience to do it. And at that point, we need to provide him the tool to be able to do this. And ultimately, I think the point that everybody wanted to look at is how much does this solution cost? So again, joining the Autodesk family of products has obviously an impact on the licensing and ultimately on the cost. So Autodesk has been fantastic into being able to democratize a lot of that high-end technology that we've developed over the years and brought into the portfolio of products. But at that point, that's also being able to make that accessible to users and really help the industry move forward into what that next generation of products would be. So putting a solution like TruePath in context with similar type of features that may need to come from multiple vendors, if we're looking at, just having a post-processor developed, making sure it's going to work accurately and properly, getting a simulation solution in place, getting the proper machine model implemented, doing that implementation and verification on top of the post-processor development. That not only takes money to purchase those items, that also takes resources from you as a customer, because now you have to dedicate not only the equipment, but also the people to run that process and really make sure all those elements are working the way they're supposed to. And that is really the over 20 years of experience that CAMplete had developing those elements and bring all that into a package that does make sense, not only from a technology perspective, but also from a commercial perspective, and is accessible to the largest majority of users. So just to kind of quickly reiterate, we're not necessarily supporting every machine tool available in the market. We can certainly dive into the specifics with Eric and his team and Andy here on the call. Again, I'm more than happy to dive into some of those specifics, but really to make sure that all of those elements are working the way they're supposed to. This is really where we've taken the approach to work with very specific machine tool builders, but that is not the limitation of the product itself. We can definitely support other machine tools other than the logos, outside of the logos that are shown here. But again, definitely a conversation to have with Eric and NexGenCAM as a.
Just to introduce NexGenCAM, we are the largest CAM reseller for Autodesk nationwide, and those are just some of the services we offer below. A number of trainings. I can go to our website and click on the training tab, and you'll see a calendar of those trainings available to you. We do custom training as well. Just had a customer reach out yesterday, said, well, that training doesn't exactly fit what we're looking for. Well, what are you looking for? And we customize the training for them to fit their needs. In addition to that, we have great news for you guys. If you're interested in CAMplete, if you're taking a look at it, if you want to jump on this, we'd love to talk to you, and we'd love to couple that with a new offering that we have. We do have CAMplete training coming up in October and November that for those first-time CAMplete users, we can support and assist you guys as you learn and walk with you guys in growing in CAMplete. It's online on our calendar, and let us know what needs you have moving forward.
The post-processor is concerned, everything is fully open. So we have developed over the years, obviously, the overall architecture of the post-processor with the machine tool vendors themselves, but as a whole, everything is fully open and basically reads just like a regular program. So how do we start a program? How do we do a tool change? What type of cuts are going to be done? And in those different sections, everything is basically handled so that a user that does not have a PhD in computer sciences can handle that. So that means if you don't like where, for example, the comment comes out, so grab the comments and put it down on whatever line you want it to come out. And if you want to add any other new machine functions, so for example, we can do, I don't know, TCPC or dynamic workpiece compensation. We can literally grab the instruction, drop it on the line where you want it output, and is it active or inactive? And then after that, depending on if the CAM system has that information available in the output that was produced, then that particular output on that line will be coming out exactly where you want it. And if you really wanted to dive a lot more into it and start building conditions and logic and macros and things like that, the same way all of those conditions and logic are available in plain English, and it's literally a drag and drop, and you have access to everything. So we provide the architecture, we provide the first go at it, which we know is going to cover 98% of what a user may be able to do with that particular machine tool. But if you want to have access to any type of customization, everything is fully open and you have full access to it and can do it on your own. And then at that point, NexGen or Autodesk will be here to support you as well if you have if you run into any type of roadblocks with that process. So we do have a multitasking product which is called TurnMill. That has a slightly different focus than TruePath, but TurnMill right now is strictly dedicated to the Nakamura Tomy line of machines. So that is a little bit of that legacy product that we brought along with the acquisition by Autodesk, but we still have existing agreements in place with Nakamura where it is exclusive to the Nakamura Tomy line of machines. So unfortunately, at this point, we're not able to support Okumas or Mazak Integrex or DMGs or anything of that nature for multi-axis machines. We can definitely support those on the 5-axis milling side of things, but specifically for multitasking right now, it is limited to Nakamura Tomy only. I have not seen any plans, any development towards switch style machines. But by default, the safety of the equipment will be the primary driver. And that is exactly why most post-processors are developed in that way, which is really safeguarding the integrity of the equipment. That being said, exactly to your point, when you're doing production runs, for sure, at that point, if you have 10,000 of the same parts to make, if you can shave half a second here, half a second there, over 10,000 parts, that has a pretty drastic impact on the revenue of your business. So at that point, yes, there is definitely a way for us to do this. So again, that's going to be a little bit of a combination of how the project as a whole is set up and how the post-processor in itself handles those movements. So in some of those retract movements, by default, it will be retract to the home position of the spindle, but we can define what is called safety volumes around particular elements. So whether that would be just the part, just the fixture, or the overall extent of the toolpath, and we can define the bounding elements around let's say the parts, and then at that point we can start optimizing the retract to not go all the way to the home position, but only clear that particular safety volume. So I'm just gonna see if I can, there you go, show safety volume page. Okay, so now when I go to look at my actual project, this is exactly what now is going to be shown. And again, as I was saying, the post will have to slightly be updated, and the team can help you do that. So now on the safety volume, I can say, okay, let's include the part, the fixture, and define those elements. And now we can start optimizing the retract, not to go all the way to the home position, but really just clear that safety volume that was defined here and keep all of those movements not any further than that safety volume, just enough to clear this and then go back down and continue to cut from that point on. So yes, we can definitely do that. Just takes a little bit more work on the implementation, but it's really not a heavy lift by any means. Yes, so NXCAM, it's not a full-on plugin that will export the models. The models themselves will have to manually be exported, which again is not too much of a heavy lift. It's simply export in STL.IHS. Specifically for the actual toolpath information and tooling, we are basically piggybacking on the CLS file format that has been enhanced on our end. So there is a custom CLS format that we would provide that at that point has been extended to pass additional information for the tooling, the holder shape, and so on. So yes, there is a similar way to pass that. Just one thing to note on the export of the models, sometimes in larger platforms like, for example, NX or CATIA, if you're working in an assembly, the parts, when it gets exported, may be exported in the assembly orientation, not necessarily the machining orientation. So again, in TruePath, there are tools in place where now we can reorient each element individually, independently of the other element. So we'll be able to realign, for example, we'll be able to see that the toolpath versus the parts and the fixture. So the toolpath and the fixture may be in the machine orientation, where the part may be in the assembly orientation. So we're able to realign everything, just something to keep in mind. So yes, out of NX, we'll be able to export all those as well. So NTC, CNC, we have seen very sporadic usage. It's basically less than a handful of customers. So it may not necessarily have the same level of support as platforms like Fusion or NXCAM that are very common. But again, more than happy to revisit that. Maybe something we should take offline. As far as now grow machines, and that's really again one of the interesting points of TruePath here. Now we can take that project that we've been working on for half an hour with all of the changes we brought forward that was originally designed for a vertical CNC machine tools, and now we can take that project with all the changes we've done, put that onto a grow machine that is completely different in terms of kinematics and controller, and it's literally a matter of saying, pick the new machine. We'll slightly realign the parts very quickly. So I'm going to do that very quickly on the screen now. But yes, everything will be handled. And while I'm doing this, just something to know about Grobe and German machine tool builders in general, they provide serialized 3D models of the machine. So that means the 3D models that we're getting are very specific to a particular machine tool and are unique to your set of options that you have ordered for that machine serial number. So at that point, this is something that if you're interested, we can definitely talk about with Grobe and put you in touch with the right people and walk you through all this. But yes, as a whole, those machine tools will be are supported. And that's literally what I'm quickly doing here, and make sure that this entire project that we've been working on now is going to be running onto that the Grobe machine. So just realign everything. Just going to generate code, but right away we can see that yeah, that entire project will be going through. And again, whether that comes from Fusion, PowerMill, really any other platform, as long as we're doing the code generation, you'll be able to flip back and forth between all those different machine tools, even if they have different kinematics or different controllers. There we go. There is that project running now onto that Grobe machine. Accommodated a very large number of different machine kinematics. So at that point, the CAMplete team has really provided the framework to develop those. We'll be providing the initial draft or the first goal on the post-processor, but would there be any changes needed? And at that point, it's a little bit on a case-by-case scenario. If it is something that can be handled at the post-processor level, for sure, the team will be here to help you support that. Because of how the post-processing is handled, specifically in toolpaths, some of those functions are handled within the software directly, not at the post-processor level, but really within the architecture of the software itself. So at that point, if it is one of those situations that need to be addressed at the software level or software architecture level, then at that point it becomes a little bit of a business case discussion and say, okay, is that investment to support that particular machine configuration that was not in there, is that something that will benefit the larger number of customers over the long term? So it's going to be a little bit of a case-by-case scenario, but generally speaking, we have covered a very large number of those. And we're here to help you support those, and obviously you have access to everything. Yeah, so any type of changes into the process, whether it's here, I can flip a solution, I can do any type of changes into the code. I can go in there and say, I need to offset that position, offset it by, 100,000. So any type of changes, whether it's at the process or the post-processor level, will automatically trigger a regen. So at that point, we don't even see the code, so everything has always have to be in sync, both on the code side and the simulation side. So yes, any changes at the process, the code, or the post level will always trigger a regen to make sure everything is always in sync. Yes. So the Robodrill machines, yeah, 100% are definitely supported. In the different configurations of Robodrills, typically the CAMplete team will do the integration of the models and tie everything to the kinematics of the machine. So part of those are really, where is your rotary table located? Is it on the left side, on the right side? Is it aligned with the x-axis, the y-axis? So some of those questions, I'm just going to literally pick the first one up here, will have to be answered, or that information provided by the customer. We've obviously gone through quite a few setups already. But again, if any changes are needed, we'll be able to address those. Where did it go? Fanny Robodrill, go. But yes, within the machine setup in itself, there is the ability to move some of those elements. But if those changes are more than adjusting a slight position, location, and so on, so we can look there, for example, on the table, we have some of those configurations presets in there. So we have Sudocoma table, Likert tables, some other Fanuc tables, and so on. So we'll be able to adjust slightly some of those positions, but if the changes are really drastic and say, okay, I have the line here with the x-axis, I need a line with the y, that is a pretty drastic change in the kinematics of the machine. So at that point, this is something the CAMplete team will have to do for you. But yes, you will have some flexibility in there. But the process to do those changes is very straightforward. Typically, we would do that the same day or within a couple of days. The updates on the software themselves are handled through an updater app. So the same way, well, now that's all going to be handled through your Autodesk account. So when there is a new release of the software that comes out, and the same thing holds true for all the different plugins that we're providing for the different versions of each CAM system, users will get the notification into their Autodesk app and say, hey, there is a new release for the software, there's a new release for the plugin. And they get the notification, and at that point, the user can choose to download and update, or simply continue with the current version that they have available to them. Sure. So as far as the learning curve of the product, I totally understand that it can be a little overwhelming. But obviously, I've been using the product for over 10 years, so I'm not necessarily the best reference there. But as far as usage and training and things like that, it really comes down to your own level of comfort with the process as a whole. We have seen users that are very comfortable with the programming aspect of things, really understand what is happening on the programming side, really have a very good understanding of the machines, and at that point, that connection is really that. It's just making the connection between what's happening on the CAM side, how the machine's going to react, and TruePath really falls in place. That's why we have all of those plugins that have been developed to really help making that transition and really focus on what is important. And a lot of the features are really, the way the software has been designed is really to kind of follow the same logic as what a user would typically go through. So as long as that base understanding is there, we have literally seen, and I have plenty of examples of users that install the software in the morning, and in the afternoon, they're literally cutting an impeller in full 5-axis. So literally the same day. So it really comes down to, I guess, your level of comfort with the manufacturing process as a whole. And of course, having great partners like NexGenCAM that will really help you navigate that and really get you up to speed to where you need to go. But as a whole, it's definitely not as heavy in terms of training as what it looks like. And our experience training customers has really been to focus on the essentials of what you really need to get going with the product and really get going into making parts, not necessarily overloading the user with all of the functions, all of the capabilities of the software, and the software can do it all, but don't really know how to use it. So we really want to focus on really the core elements. How do you get code? How do we fix the first immediate collisions or issues and really get you comfortable with the process and the product and build your confidence? And as time goes on, then we can dive and take a little bit more time into optimizations or some of the more advanced functions. So as a whole, generally speaking, we've seen users get trained very, very quickly and become very efficient. And that's really why the tool was designed to do this and be efficient and help customers make parts.